Okay, let's get back to it. Part 2. Okay, so in part 1, we just finished looking at the standard form and drawing the graphs. So then the second part of this section is the general form. So we're looking now at f of x is ax squared plus bx plus c. So we want to be able to graph doing all of the same things that we just did with the standard form. It's just that there is one part that's a little bit uglier, and that's the vertex. So, and the problem is that in this one, the vertex is not as easily just written right there as it is in the standard form. So in order to find the vertex, we have to do a little formula. We're gonna take negative b over 2a. Negative b over 2a. We're going to calculate whatever that is. When we find that, we're going to take it and we're going to stick it right back into the function. So we're going to find f of negative b over 2a. So I know right now at first it looks a little bit ugly, but it's not really as bad as it seems. The formula makes it uglier than it actually tends to be. So anyway, that's the worst part of this. Then the axis of symmetry is still just that vertical line down the middle, but in this one, it has the form x equals negative b over 2a. So that part is the ugliest part. Now, we still have an a out front, and so we still have our opening, okay, and nothing changes with that. So opening. If a is greater than 0, we're going up. And if a is less than 0, we're going down. And then we have intercepts. So intercepts. So same things that we were doing before, it's just this part right here is a little bit uglier. So let me give you an example. And we'll see if we can graph these guys. All right, what do I got here? Let's go with this one. So the first one I'm giving you is f of x is x squared minus 4x plus 3. And again, it's going to ask you for all of those same things: vertex, axis of symmetry, opening, intercepts. Okay, so again, you're going to find all of them, and then we're going to use that all to get a nice graph with at least 3 points on it. So let's start with the vertex. But remember, in this one, this is where it takes a little bit to kind of figure this out. So instead of just picking off numbers, we need to go negative b over 2a. So in our case, negative b over 2a is going to be positive 4 over 2 times 1, which is just 2. So the first coordinate of our vertex is going to be 2. But we also need that second coordinate. And the way we find that is by taking whatever we got right here and plugging it back in and solving it out. So we're going to find f of 2. So we're going to go 2 squared minus 4 times 2 plus 3. So that's going to be 4 minus 8, so we're at negative 4, and then plus 3, so we're at negative 1. So that goes right in there. So our vertex is going to be the point 2, negative 1. Now, our axis of symmetry is just going to be that line running through the vertex. And by looking at this one, the parabola is opening up, correct? Opens up. Oh, I forgot the opens up. Okay, so let's start drawing a graph over here. Nice big graph again. Okay, so we know that our vertex is going to be over 2 and down 1. So there is our vertex point, and we know that we have this axis of symmetry running like that. Okay. Now, the other things that we need to find are the x and the y intercept. So if we start with the y intercept, The y-intercept in this form is actually the easiest point to find because all we're doing is plugging in x equals 0. And if we plug in 0 for x, everything is going to fall away except the 3, isn't it? So plug in 0 and we get 3. So we now know that we have the point 0, 3. And then in this part, even the x-intercepts aren't that bad either. For the x-intercepts, we're going to take this guy and set it equal to 0. So we're going to say x squared minus 4x plus 3 equals 0. And if we're in a quadratic in its general form, the hope is that we can take or that we can factor it, okay? So that's what we're going to do. So we're going to hope that this guy factors. So x is up front, and a 3 and a 1 in the back. And if they're both negatives, will we get a -4 in the middle and a +3 at the end? Okay. Which means that we have x equals 3, and over here we've got x equals 1. So that's the point 3, 0, and the point 1, 0. Okay. That's helpful to us. Okay, so this time we have a lot of really nice points going on, no square roots and ugly things, fractions or anything like that. So we have 0, 3, so over 0 but up 3. We have 3, 0, which would be here, and we have 1, 0, which would be here. Now notice, there's symmetry going on there. Now like I said, we only need 3 points. We already have 4. And if we wanted, even though we don't need it, if we wanted, could we use that axis of symmetry to find the point that if we're 2 off in this direction, we're also going to be 2 off in that direction? So would we have that point as well? And now we should be able to give a really nice, precise parabola. Okay. That's pretty good for me. That one deserves like maybe a picture, okay? Well, I guess it's on video, isn't it? All right, so there we go. So we used vertex, axis of symmetry, opening, and our intercepts in order to find that guy. Now, one other thing that they're gonna ask you to do, and I never understood this, I don't get it, is they're gonna ask you to switch from general form, they're gonna say switch to standard form. I don't know why, but if you've done all this work, we can make this switch really easily. So if we want to switch to standard form is going to have that A out in front. Now our A here is 1, so in our standard form, we're going to have a 1. Now, in the standard form, we're going to have x and then something or other squared and then another something or other there at the end. And that's our vertex, isn't it? So to get to our vertex, we went over 2. But do you remember what the tricky part is? This is not going to be a +2, it's going to be a -2. So it's going to be x minus 2 over 2 down 1. So that'll be a -1 on the end. So to switch this into standard form, whatever your A is, put it out in front. And then whatever your vertex was, flip the sign on the x value. So it was a 2, so it's a -2. Leave the sign on the y value. I don't know why you'd want to switch forms if you've already done all the work, but oh well, we did it, okay? So we've got it. Okay, so let's do another one of those. I've got one that's a little bit uglier looking here. Okay, so let's go back to blue. So this time I want you to draw the function g of x equals 6 minus x squared. And there is a bit of an issue with this guy in that it is written up there out of order, if you will. So I would go through here and rewrite this as minus x squared minus x plus 6. Having everything in the correct spot just makes it that much easier to get this correct. If things are out of order, it's that much easier to get it incorrect. So we won't use that, we'll use this instead. Now they were trying to mislead you with this form so that you didn't realize that how does this parabola open? And it opens down, doesn't it? So this guy opens down, alrighty. So that's a piece of an important piece that we need to know. Now, our vertex here is going to be the negative b over 2a again, negative b over 2a, and we have some negative signs going on. So this time, our negative b is going to be positive 1 over 2a is going to be negative 2. Everybody agree? So we're actually going to have negative 1/2 for the first coordinate of our vertex. Okay, that's going to make the rest of this just a little bit uglier. So in order to find the second coordinate, we're going to plug in negative 1/2. So we're going to have negative 1/2 squared minus negative 1/2 plus 6. Ugh. Okay, so that negative is going to go away, but that one's still there. So this is going to be negative 1/4. That's going to be plus 1/2, and then this is plus 6. So I think the easiest way to do this would be to switch everybody into fourths. So we'll go negative 1/4 plus 2/4 plus 24 fourths. You're right. So negative 1 plus 2 puts us at positive 1, and then 25, right? So 25 fourths. And this, if it was 24, would be 6, right? So this is a little over 6. And that's the way I would think about it in my mind. You don't need your calculator. Just think about it. It's a little over 6. Okay. All right, so we've got the point then. Our point is negative 1/2, 25 fourths. Okay. Then our intercept, our y-intercept, if we go g of 0, what pops out is the 6, right? Plug 0 in, boop, boop, out pops a 6. And if we want our x-intercept here, we're going to set this guy equal to 0. So we're going to say negative x squared, minus x plus 6 equals 0. Now, important, at this point, and only at this point, never before this point, this negative has to stay here through this whole problem, all of this problem, all this problem. But when you find the x-intercepts is when you can actually eliminate the negative. Because what you're doing is basically dividing the whole entire thing by negative 1. And when you divide a 0 by a negative 1, it stays 0. That is not the case up here. It has to have that 0. So I ran myself out of space, but we can now say that x squared plus x minus 6, flip all of the signs, equals 0. Okay, but it is only okay at that step. That is very important. And now the hope is that we have something that will factor again. Okay. So let's see, we've got x's up front. We need a 6, but a 1 in the middle, so we'll go with a 3 and a 2. And to get a positive 1, we'll need a positive 3 minus 2. So we'll have x equals negative 3 and x equals 2. So let's go ahead and see what we got going on here. So we're going to have to go out, we don't have to go out very far actually, we'll just say it like that. But we got to go up to 6-ish, don't we? Actually, let's go a couple more, there we go. Up to 6, 1, 2, 3, 4, 5, 6, do a couple more. Okay. So our vertex was -1/2, so I guess we're going this direction as well. So -1/2, right there. And then a little bit more than 6. So can we agree on that? Okay. Now, it's opening down, which means it's going to look like this, and it's got a y-intercept of +6. So it's got a y-intercept right here. So its y-intercept and its vertex are very close to each other. But then it has these two x-intercepts. One of them is at -3. The other one is at 2. And we've got that line of symmetry, the axis of symmetry running right down through there. So it does look symmetrical. So if we want, we can sketch down this way and down that way. Okay. And if you wanted, you could put that point right there because of our axis of symmetry. Not the greatest graph looking at it, but all we really need are those points so that we get a good idea of what the graph looks like. Now, again, it's going to say, rewrite this in standard form. Again, like I said, who knows why, but if that's what they want, we can do it. So standard form. So this was g of x. Now, on this one, and there's our stuff that's going to be there. It had a negative out in front, didn't it? So we definitely need this negative. Okay, that negative is important. Now, for our x value, our vertex was -1/2, which means this is going to be +1/2. And our y coordinate was 25/4, which just stays the same, so +25/4. And real quick, we have switched it into the standard form because we've done all the hard work over there. And then someone goes, how'd you do that so quick? And you go, well, because I already had it. Okay. All right, so we've got standard form and we have the graph to go along with it and all of the information we need. Now, one other thing that I wanted to show you in this section is this. Let's say that we had a parabola. Just a sketch here, nothing important. That looks like this. Okay. So first off, is this guy going to have a y-intercept? And for sure, every parabola is going to have a y-intercept. So we always have a y-intercept, okay? Always. But do you notice how there are no x-intercepts? Okay? No x-intercepts on this guy. And that's going to happen. Now, it didn't happen in any of the 4 graphs that we graphed so far today, but it is most definitely going to happen. So I wanted to show you why this happens and how this happens. And instead of doing the whole entire process again, because we've already practiced that a number of times, so that's not really important. Let's just show what it looks like when there are no x-intercepts. So let's say that I had given you the function